Yeah, we are back into action, and I want to welcome all of you for this lesson where I'm intending to finish polynomials and start binomial theorem. So that is my intention. I've limited some people from entry because of the factor we mentioned, but those of us who are already in, let's start. Let's start on. We were disturbed by network last time, but this time around, let's mean it and we see. So I'm going to repeat from where I had stopped. Actually, I'm going to repeat much of that work and then see how best we can do it. I want us to see how best we can do it up to where we are supposed to be. So last time we had looked at long division. We had covered all those things of long division, but this time around, I want us to look at different questions. So looking at where we are supposed to pick up from, we are looking at where we are supposed to pick up from. We are supposed to have more examples done. So I'm going to say more examples. On polynomials. My examples on polynomials. Number one, find the values of A in the expressions below if the following conditions are satisfied. So yeah, they give you conditions and they want you to find the values. They want you to find the value of A. So we want to see if the following conditions are satisfied. How do we get the values of A? One, or part A, we have x cubed plus x squared plus 3x minus 5. It has remainder 5. No, remainder 3. When divided by x minus 2. For this case, when we divide by x minus 2, we need to realize that from the general form, if I'm to do the solution very fast for this, from the general form of a polynomial, we are going to realize that a polynomial is given by the quotient of x times the divisor of x. We add a remainder. Implying that if I'm to substitute, we are given a polynomial, which is x cubed plus ax squared plus 3x minus 5 is equal to the quotient. I don't know the quotient, it is not been given, but they gave me the divisor, which is x minus 2, so I have a divisor, and they gave me the remainder negative 3. It was supposed to be negative 3, so the remainder minus 3. But we say that in all cases, if I call this one my equation 1, in all cases, you have to equate the divisor to 0. Equate d of x to 0. D of x is x minus 2. So if you equate it to 0, you're going to have x as 2. We said in our first lesson that when you get this x is equal to 2 and you substitute it within the polynomial, you are supposed to get the remainder. So implying that if we substitute the value of x into equation 1, substitute x is equal to 2 into equation 1, we shall have 2 cubed plus a into 2 squared plus 3 into 2 minus 5 is equal to, here, the moment you put that 2, it will be 2 minus 2, which is 0, so the whole of this one becomes 0, so is equals to -3. So solving this one gives 8, this one gives 4a, and some people are not muted. Junior. This one gives 4a, then this one gives +6. Then -5 is equals to -3, implying that 4a, when you work on this, 8 plus 6, that is 14 minus 5, that is 9. If you subtract it from here, it will be -12. And therefore your a is equals to 3. We had done this example, only that the network wasn't good. So if you're with me, type yes. If you're with me on that case, type yes. If you're with me, type a yes. We get -3, not 3. If you're with me, guys, type yes. Okay. So from there, let's do another example. Those ones who have just entered the class, please mute yourself. Then another example. Another example is where we have part B. If you have x cubed plus x squared minus 2ax plus a squared has a remainder 8 when divided by x minus 2. When you divide it by x minus 2. So if at all you have this polynomial and we are dividing by x minus 2 to give remainder 8, still, by writing the general expression and you substitute in it, it means that our polynomial, which is x cubed plus x squared minus 2ax plus s squared is going to be equal to the quotient. I don't know the quotient, has not been given, times the divisor, which is x minus 2, then plus the remainder, which is 8. So still in this case, you equate the divisor to 0. For x minus 2 is equal to 0, that is the divisor. It would mean that x is equals to 2. The moment you get x as 2, then you will substitute. If this is maybe equation 1, you're going to substitute x is equals to 2 into equation 1. And when that is done, it means that you will have 2 cubed plus 2 square minus 2a into 2, then plus s squared. That one will give you x minus 2, that is 0. The whole of this one will be 0 because 2x is 2. So it will give you 8. When you work on this, you're going to have 8 here. You're going to have plus, it will be 8 plus 4 minus 4a plus s squared is equals to 8. And this one will give you a squared minus 4a minus 4a. Then this is 12 minus 8, it will be minus 4, rather plus 4, giving you a 0. And if you factorize this, you're going to get a minus 2 times or square, which is equal to 0. And on solving that, you get your a as 2 also. So in that case, you're given a polynomial, and you use a polynomial to get the values of the constants that are needed. Without wasting much time, because I have gone through what we have talked about before. So allow me to look at a different thing. Let me look at a different thing. So example 2. Example 2 reads, show that 12x cubed plus 16x squared minus 5x minus 3 is divisible by 2x minus 1 after find other factors. Find other factors. This is as easy as you can imagine. The moment they want you to show that it is divisible, if you want you to show that it is divisible by this, it means you have to first carry out long division. You divided a polynomial by 2x minus 1. The fact that I've said it is divisible, it means that it has to leave remainder 0. So by long division, we are going to divide. By long division, we shall have 2x minus 1 as our divisor, and the polynomial we are dividing is 12x cubed, 16x squared, minus 5x minus 3. I guess using the first lesson, all of us can do long division. You get 12x cubed divided by 2x, you get 6x squared. 6x squared times 2x, 12x cubed. 6x squared times -1 minus 6x squared. Since we don't have components here, we shall say plus 0, plus 0. That is followed by subtraction. 12x cubed minus 12x cubed, that is 0. 16x squared minus -6x squared, that is 22x squared, minus 5x minus 0, that is minus 5x, and minus 3 minus 0, that is minus 3. Still, 22x squared divided by 2x, it will give you plus 11x. 11x times 2x, that is 22x squared. 11x times -1, that is minus 11x. Because we don't have a component here, we shall say plus 0, and then we subtract. The moment you subtract, 22x squared minus 22x squared will give you a 0, minus 5 minus -11 will give you 6x, but -3 minus 0 will be minus 3. 6x can be divided by 2x to give us 3, then 3 times 2x will give us 6x, and 3 times -1 to give you -3. The moment you subtract this off, you're going to get 0, 0. The fact that it has left remainder 0, it means that this polynomial is divisible by 2x minus 1. So you have to do the conclusion and say, since remainder is 0, since remainder is 0, comma, the polynomial 12x cubed plus 16x squared minus 5x minus 3 is divisible by twice x minus 1. If you're with me on how I've proved how it is divisible, type yes, and we proceed to looking for other factors. Type yes, and I look for other factors. I see one person, that is Onenchan, Waliaula, Junior, both. That is interesting. So, Tumusime. Okay, now to summarize the whole gap, let's see how we get other factors. What does it mean? The moment you have proved that it is divisible, write the general form. It means that our polynomial 12x cubed plus 16x square minus 5x minus 3 is going to be equal to, we say that it is always equal to the quotient, the polynomial is equal to the quotient, but my quotient is 6x square plus 11x plus 3 times the divisor, so which is the same as the divisor times the quotient. So we have the divisor, which is 2x minus 1, times the quotient, which is what you've gotten here on top. There is 6x squared plus 11x plus 3 plus the remainder, but the remainder is 0. So this is the first factor because the polynomial is divisible by it. So that one makes our first factor. So to get other factors, we have to factorize this. So I will say factorizing 6x squared plus 11x plus 3. It means that 6x squared plus 11x plus 3 is equal to, look for the factors, which one multiplied gives you 18 because our product is 18, and which when added gives us 11, and that is 2 and 9. So if the factors are 2 and 9, it means that it will be 6x squared plus 2x plus 9x plus 3. On factorizing, you can group them. So this is the same as the common factor here is 2x into 3x plus 1. Then here what is common is a 3, still into 3x plus 1. So this one will give us 2x plus 3 and 3x plus 1. So these are other factors, meaning that it would mean that other factors are, other factors are 2x plus 3 and 3x plus 1. So that is how we look for other factors. If you're with me, please type a yes and I go to another example. If you're with me, let me see you type yes and we go ahead. That is good. If you're not with me, please ask. Oh yeah. So without wasting time, I told you that this topic today has to come to an end and true. So if that is okay, type a yes. I take you to the third example. The third example says x plus 2 is a factor of x plus 2 is a factor of x plus 2 is a factor of 2x cubed plus 6x squared plus bx minus 5, full stop. Find the remainder. Oh, no. Find the value of x, of b, sorry. Find the value of b. Find the value of b. So here, this question, we need to first understand what it means when they say x plus 2 is a factor. When they say x plus 2 is a factor, it means that when we divide the polynomial by that x plus 2, the remainder is 0. So what does it mean? P of x, our polynomial, that is my solution. Our polynomial P of x is equal to 2x cubed plus 6x squared plus bx minus 5. Since x plus 2 is a factor, the moment they say is a factor, then it means that the remainder is 0. So first equate the divisor to 0. So equate, but you don't equate the divisor to 0 because the remainder is 0. No, you equate the divisor to 0 because we proved that if you equate the divisor to 0, the value of x you get, when you substitute it within the polynomial, you're supposed to get the remainder. So for x plus 2 is equal to 0, it means that x is equal to -2. So look for p of -2. P of -2 will be 2 into -2 cubed plus 6 into -2 squared plus b into -2, then minus 5. So this one will give you the value of p of -2 as, this is -8, so times 2, that is -16. Yeah, so -16 plus, this is 4 times 6, that is 24, minus twice b minus 5. So we shall have p of -2 as 3, because when you get this, it will give you a 3 when you get this, and this. We shall have 3 minus 2b, yeah? But we have substituted the value of x to get this, meaning this one is our remainder, because we say that when you substitute the value of x into the polynomial, what you get is the remainder. But literally, because x plus 2 is a factor, the remainder must be equated to 0. So we shall say this implies that 3 minus twice b, 3 minus twice b is equal to 0. So implying that my b, okay, my 2b is equals to 3, and therefore b is equals to 1.5. As simple as that. If you're with me, guys, type yes, because now we are moving very, 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 very fast. If you're with me, type yes, and I see. Oh yeah, oh yeah, oh yeah. Provided you understand, guys, I want you to always complete these things by yourself. If you understand, you can be like, oh, I'm going to complete it tomorrow. I'm going to complete it as I'm revising. So allow me to remove it for another example 4. Example 4, I'm intending to do you 8 examples. And those 8 examples will be making you able to do all the questions you come across in the tube B. The remainder obtained when 2x cubed plus x squared minus 6x plus 1 is divided by x plus 2 is twice the remainder obtained when the same expression is divided by x minus 3. Find A. The moment they give you such a question, you need to first thank God for it before you even do it, because it is very easy. It is very easy. Solution. When we have to first write our polynomial of x, p of x is equal to 2x cubed plus x squared minus 6x plus 1. This is my polynomial. But I've said that when it is divided by x plus 2, what does it mean? We shall look for p of negative 2, because we first equate this one to 0. If you equate x plus 2 to 0, you get x is equals to negative 2. That's why I'm saying p of negative 2. I'm not doing this baby step. I'm just saying p of negative 2 is going to be equal to 2 into negative 2 cubed plus a negative 2 squared minus 6 into negative 2 plus a 1. This would mean that we shall have, this is negative 8, so it gives negative 16, plus 4a, plus 12, then plus a 1. So this one will give you p of negative 2 as equal to negative 3. It will give negative 3 plus 4a, because if you get 12 plus this is 13 minus 16, that is negative 3. So I'll call this one my equation 1. They have said is twice the remainder obtained when the same expression is divided by x minus 3. So if you equate x minus 3 to 0, you get x is equal to 3. So you're going to get p of 3. P of 3 is going to be equal to 2 into 3 cubed plus a into 3 square minus 6 into 3, then plus a 1. So this is equal to 27 times 2, which is 54, plus 9a minus 18 plus 1. When you work on this, it's going to give you 37, because this is 19. No. This is negative 17. When you subtract it here, to give you 37 plus 9a. So this is my P of 3. But the question is clear. If this is my question 2. From 1 and 2, they have said that the remainder obtained when 2x is divided by x plus 2 is twice, meaning that this remainder, we have gotten here is twice when it is divided by this. So negative 3 plus 4a is twice, meaning it's 2 times the remainder when it is divided by 3. So 37 plus 9a. That is what the statement meant. So negative 3 plus 4a is equal to 54 plus 18a. So when you work on it, correct like terms here and there, you're going to get negative, sorry, this is 74. You're going to get 74, you bring it this side, you get negative 77 is equal to 18a minus 4a, which will be 14a. When you divide it through, you're going to get a as your negative 5.5. If you're with me, guys, type yes. If you're with me on this question, type yes. Okay, so that is it. It didn't need much. It didn't need much suffering. Okay. Then, guys, without wasting time, example number 5. Example number 5. Example number 5, a cubic polynomial (6x cubed plus 7x squared plus ax plus b has remainder 72 when divided by x minus 2, and exactly divisible and exactly divisible by x plus 1. Calculate the values of A and B. Calculate the values of A and B, comma, show that show that 2x minus 1 is also a factor, then obtain other factors. Now here comes the case where they want you to find two unknowns. The moment you find two unknowns in the polynomial, it means you have to come up with the 3 equations. You have to come up with the 3 equations, rather 2 equations, sorry. If there are 3 unknowns, you have to come up with the 3 equations. But if there are 2 unknowns, you have to solve 2 equations. Yeah. So for this case, we shall have for this case, they have given us even 2 cases. They have said that it has remainder 72 when it is divided by x minus 2, meaning that x of 2, because you need to first equate the divisor to 0, x of 2 gives remainder 72. In other words, first write as your polynomial p of x is equal to 6x cubed plus 7x squared plus ax plus b. When they say it's divided by x minus 2, just equate x minus 2 to 0, implying that x is equal to 2. So you look for p of 2, and p of 2 will be equaling to 72. We shall do that and we get it. Then another thing they told us that it is exactly divisible by x plus 1. It means that if you equate x plus 1 to 0, you're going to get x is equal to -1, implying that p of -1, since it is divisible, the remainder is 0. After you knowing this, then you are mature. So look for p of 2. P of 2, substitute 2 wherever you find x there. It will be 6 into 2 cubed plus 7 into 2 squared plus a into 2, then plus b. So this one will give you 48 plus 28, because this is 4 times 7, then plus 2a plus b. When you work on this, it's going to simplify to 76 plus 2a plus b. But p of 2 is 72, so 72. When you reduce this, it is going to be -4. When the 76 comes this side, it's going to be -4 is equal to 2a plus b. Call this one your equation 1. Get p of -1. P of -1 is equal to 6 into -1 cubed plus 7 into -1 square plus a into -1, then plus b. But p of -1 is 0 because the remainder is 0. So 0 is equal to -6, because this will give you -6 plus 7 minus a plus b. Reducing it, it's going to be -1 because remember this is going to be 1 when it comes this side -1. It is going to be equal to -a plus b. Call it equation 2. You have to solve equation 1 and 2 simultaneously, so we can subtract them. simultaneously because you said b and b can be eliminated. So if I get equation 1 minus equation 2, I'm going to have 2a minus negative a, that will be 3a. B minus b, that is 0. So negative 4 minus negative 1, that will give you negative 3, implying that a is equals to negative 1. And when you substitute for a in any of these two equations, so substitute a is equal to negative 1 into equation 2, it means that negative 1 is equal to 1 plus b. So you realize that here my b is going to be equal to negative 2. That is if at all negative 1 comes this side. It will be negative 1 minus 1, which is negative 2. After getting this, it means that now my polynomial p of x is equal to 6x cubed plus 7x squared plus ax. A is negative, so it will be minus x. Yeah, it will be minus x. Then b is negative 2, so it will be minus 2. So that is my polynomial. After getting the polynomial, they need the values of a and b, but then you cannot proceed when you have not substituted for them into the polynomial. After getting this, they want you to show that the polynomial is divisible by this, because if they say show that 2x minus 1 is also a factor, it means that for it to be a factor, you must be dividing it in this, and it gives the remainder 0. So to show that 2x minus 1 is a factor, we use long division. When you're using long division, of course, you're going to divide. It will be 2x minus 1. But you're dividing, what are you dividing? The polynomial, 6x cubed plus 7x squared minus x, then minus 2. You divide each component. 6x cubed divided by 2x. You'll be getting a 3x squared. No. Will it be divisible? I doubt. Let's divide and see. You'll get 6x squared. You divide by 2x. You're going to get, actually it is 6x cubed divided by 2x. It is going to be 3x squared. 3x squared times 2x, it will be 6x cubed. 3x squared times negative 1 minus 3x squared. We don't have a component here, 0, and also here, 0. When you subtract this, 6x cubed minus 6x cubed, that is a 0. 7 minus negative 3, it is going to be 10x squared. Minus x minus 0, that is minus x, minus 2 minus 0, that is minus 2. 10x squared divided by 2x. It will give you 5x positive. 5x times 2x, that is 10x squared. 5x times negative 1, that is minus 5x. Here we don't have a component, so as 0. Subtract that. 10x squared minus 10x squared, that is 0. Minus x minus negative 5x. Minus x, you have minus x minus negative 5x. That will give you 4x, yeah? So we shall have 4x minus 2 minus 0, that is minus 2. 4x divided by 2x. 4x divided by 2x. 4x by 2x, you get a 2 plus 2. Then 2 times 2x, that is 4x. And 2 times -1, that is -2. When you subtract, it gives remainder 0, 0. So they said show that 2x minus 1 is also a factor, and therefore you'll be saying that since the remainder is 0, then 2x minus 1 is also a factor. So you'll be saying since remainder is 0, then 2x minus 1 is a factor. Now, they want you to find other factors. We began by getting values of a and b. We showed that this is a factor. Now we need other factors. How do we get other factors? To get other factors, you need to first write the general expression. Yeah. So I'm rubbing it off because I cannot find other factors when it is not rubbed off. So we've gotten the quotient as 3x squared plus 5x plus 2, and the divisor is 2x minus 1. So what do? I'm just going to rewrite it, and then I get other factors, yeah? So let me rub it off and say that my polynomial, which is 6x cubed plus 7x squared minus x minus 2 is going to be equal to the divisor, which is 2x minus 1 times the quotient, 3x squared plus 5x plus 2 plus the remainder, but the remainder is 0. So this is the first factor. To obtain other factors, we shall factorize the quotient. So factorizing 3x squared plus 5x plus 2, it means that's 3x squared plus 5x plus 5x, then plus 2. This is equal to, of course, you need the values which when multiplied gives you a 6, and then when added gives a 5, and that is 3 and 2. So it will be 3x squared plus 3x, then plus 2x. This one is when you multiply them, you get a 6, and when you add them, you get 5, then plus a 2. You factorize out 3x being common to be 3x into 3x. No. When you factorize out 3, it will be just x plus 1. Then here a 2 is common, so it will be 2 into x plus 1. This one would mean that you will have 3x plus 2 and the x plus 1. So other factors are 3x plus 2 and x plus 1. As simple as that. So if you're with me, or if you can go through it by yourself, please type yes. If you can go through, some members are enjoying. I don't know what about others. Yes, Precious. Precious. Any comment? Okay, so if that is okay, I'm going to give you a question related to this, but this one involves you getting 3 equations and you solve 3 simultaneous equations. I'm assuming that in your basic mathematics of Form 5, you learned how to solve 3 simultaneous equation expressions. So here is a question for you guys. X minus 1 and x plus 1 are factors. Are factors of x cubed plus ax plus bx plus c. X minus 1, x plus 1 are factors of this expression, and it leaves the remainder of 12 when divided by x minus 2. Find values of A, B, and C. The moment they say A, B, and C, you have to come up with 3 equations and you solve them simultaneously to get the answer. So if you can do that, members, type yes. If you can do that, type yes. And I want you to find out that the values, let me give you answers, should come up with A as 2, should come up with B as -1, and should come up with C as -2. If you get different answers, repeat, and keep repeating until you get those answers. You should be able to solve 3 simultaneous equations. Okay. I'm going to my final section of polynomials, and I call it polynomials. I'm going to my final section of polynomials, and I call it polynomials. Yeah. Before I go to that section, I want you guys, in addition to this, I want you guys to try this. This is also this is an enable question. When the quadratic polynomial AP squared plus BP plus C is divided by P minus 1, P minus 2, and P plus 1, the remainders are 1, 1, 25, respectively. Determine the factors. Determine the factors of expression. Determine the factors of the expression. Being a quadratic polynomial, it means that after you getting the values of A, B, and C, you can factorize it normally using factorization method, and you get the factors. Meaning, if it is a quadratic polynomial, it has 2 factors. If it is a cubic polynomial, it is having if it is a cubic polynomial, it must be having 3 factors. If it is a quadratic polynomial, it must be having 2 factors. So for this case, you're going to first use these conditions they have given you. You get the values of A, B, and C. After getting the values of A, B, and C, and in that case, still the answers, you're going to get the value of A as 4. You get the value of B as -12. You get the value of C as 9, and you'll get the factors. You get the factors as 2p minus 3 and the 2p minus 3. It is a repeated factor. So I expect you guys to get such when you carry it out. Finally, still, I'm going to give you another question for you guys to do. Also, in relation to what I've done, Another question, express. It is also a enable question. 2x cubed plus 5x squared minus 4x minus 3 in the form x squared plus x minus 2 times quotient of x plus ax plus b, where q of x is a quotient but is a polynomial in x, and a, b are constants. Determine values of a and b and expression q of x. That is also your question. Very easy, very easy. Don't break yourselves. They have said that express it in this form. It means that if this is the quotient, then this is the divisor. So in this case, divide this polynomial by long division with this divisor. It will give you the quotient on top, and then it will give you the remainder. Of course, this is the remainder. So I don't want you to break yourselves by suffering, looking at how to divide it or what not. No. X squared plus x minus 2 is a divisor. Divide, it will give you the quotient and the remainder. Get the coefficients here and do what is necessary. If you can do this exercise, members, type yes. For this case, you must get your q of x as 2x plus 3. And you must get your value of a as -3 and value of b as +3. So everyone must try doing this work. Then now I'm going to the final question, which appeared even in last year's UNEB. That is the case I'm going on, and we call it a day. For this case, I call it example what? More examples. Here I'm going to do only 2. I have 20 minutes, so in 20 minutes I'm supposed to be done. More examples. When a polynomial, here they don't define it, they don't give you a polynomial. When a polynomial px is divided by x minus 2, the remainder is 4. The remainder is 4. And when px is divided by x minus 3, the remainder is 7. Find the remainder when px is divided by x minus 2, x minus 3. That format, this format of a question came in UNEB last year. And after doing this example, I'm going to give you that question of UNEB last year and you do it. Okay, so here we are. The moment you're given such a question, you first count 3 marks and then you go ahead to do it. Solution. You should know that generally P of X is equal to quotient of X times the divisor of X plus the remainder. But in this case, when the divisor is quadratic, because when you expand this, it goes to quadratic expression. The remainder also is in X. The remainder is in X. That is the difference. Now, another thing you should know that the moment they give you a quadratic divisor, the remainder is in the form AX plus B. Also, remainder is in form AX plus B. That's another thing you should know. Implying that my P of X, if I'm to put the information given, my P of X is equal to quotient of X, which I don't know, times the divisor. Bring this quadratic divisor. These ones are components of this quadratic divisor. So times X minus 2 times X minus 3 plus the remainder, but my remainder is in the form AX plus B because of the nature of the divisor. So they have said that when a polynomial is divided by X minus 2, the remainder is 4. But P of 2, because you equate this to 0 and you get X as 2. So P of 2 is equal to 4. And P of 3, when you divide by X minus 3, it will be P of 3 is 7. So it means that when we substitute by 2, we should equate to 4. When you substitute by 3, we should equate to 7. This implies that when you substitute by 2, we shall have P of 2 after equating the divisor to 0, because this is the divisor. So X minus 2, X minus 3. So P of 2 is equal to substitute. It means that the whole of this, it will be 2 minus 2, where X is 2 minus 2 is 0. The whole of this is 0. So we shall have 2A plus B. 2A plus B. But we know that P of 2 is 4. So 4 is equal to 2A plus B. Equation 1. Substitute by 3. When you put in 3, P of 3 is equal to, when you put here 3 minus 3 would be 0. The whole of this would be 0. So it will be 3A plus B. But P of 3 is equal to 7. So 7 is equal to 3A plus B. And I call this from my equation 2. Solving 1 and 2, but you can get equation 2 minus equation 1. You get 3A minus 2A, you get A. B minus B 0, 7 minus 4, that is 3. So A is equals to 3. When you substitute A is equals to 3 into equation 1, you're going to have 4 is equals to 2 times 2, which is 4 plus B, implying that my B, myself, A is 3. So here I have 6. So my B is negative 2. So they want us to find a remainder, but we know that our remainder is the AX plus B, and we've already gotten the value of A, we've already gotten the value of B. So remainder is A, which is the 3X plus B, which is negative 2. So to avoid being local, just say R is equal to 3X minus 2, and that is my remainder. If you're with me, type yes. It's just a matter of knowing that the moment you're dividing by a quadratic polynomial or a quadratic equation, the remainder is in the form AX plus B. Guys, if you're with me, type yes. Then I give you 2 questions to do on this case. because mine is a proof, but I want to give you 2 questions. You just follow the route and you do them. People are typing yes, slowly, slowly, slowly. It is okay for me. It is okay for me. You're going to do these 2 questions when a polynomial is divided by x minus 1, the remainder is 5, and when divided by x minus 2, the remainder is 7. Find the remainder when the expression is divided by x minus 1 times x minus 2. Then another one is UNEB 2020, number 9. And I'm interested in you guys to do part A, because part B is on binomial theorem, which we are going to start in our next lesson. So when we finish binomial theorem, you're supposed to be completing all these. So a polynomial, this was very direct. They made it easy for these learners. Px is given by Px is equal to x plus 2, x minus 1, 2x, ax plus b, where 2x is the quotient and x plus b is the remainder. When Px is divided by x minus 1, the remainder is 4. And when it is divided by x plus 2, the remainder is 1. Find the values of A and B. If you do me those numbers, members, God will bless you. So me, I'm going to do my final question. I'm going to do my final question, which will take us like 10 minutes. 10 minutes, yeah, because I'm having 9, but I want it to take us 10 minutes because it is a reflection of these last examples I've done, of these numbers which we are doing right now. If you're done copying, type yes. If you're done copying, type yes, so that I move forward. If you are done copying, type yes. So you copy this question. It is in UNEB 2005. This question is UNEB 2005. Let me check that it should be. But what I know is the year 2005. It was a tricky question. UNEB 2005. Yeah, UNEB 2005. Number 14, pure math, number 14, part B. 2005, number 13, part B. It's the number I'm going to prove, and then we say bye-bye to polynomials. I will say bye-bye to polynomials. The question is, given that the polynomial px, the polynomial fx is equal to 2x times gx plus rx. The moment you see rx means that the divisor will be a quadratic one, where qx is the quotient and the gx, synthetic method, leave it alone. Just leave it alone. If you want to fail, go for it. Some method, they will not say using synthetic method. The question will be okay with you. Synthetic method, I will record it and put it on my YouTube channel, but it is not necessary. Just learn how to use long division to get the remainders. Yeah, given that the polynomial is that where 2x is the quotient, gx is x minus alpha times x minus beta, and rx is the remainder. Show that. I'm interested in the show that part. Show that the remainder is equal to x minus beta f of alpha plus alpha minus x f of beta out of alpha minus beta. I'm just interested in that part only. The other part is okay. So the moment we finish this, then we shall be done with the topic. Yeah, we shall be done with the topic. So it's first of all a matter of it's a matter of knowing that since the divisor is the quadratic, x minus half x minus beta, it would mean that our remainder is in the form ax plus b. Solution. So we shall first acknowledge that f of x is equal to, they gave us 2x, gx, which is our divisor, plus rx. But back at your mind, since this is a quadratic, rx should be in the form ax plus b. So if fx is going to be 2x, then the divisor is x minus alpha, x minus beta, plus ax plus b. Looking at this, Of course, this is our R, but x plus b. So we need, this is our remainder. By getting the value of a and b, we shall be able to get the remainder. Now, another thing that you should know after reaching here, we shall equate the divisor to 0. Equate divisor to 0. It means that x minus alpha times x minus beta is equal to 0, implying that either x is equals to alpha or x is equals to beta. After equating these two equations to 0 to 0. Now, we shall first look for f of alpha, then after we look for f of beta. So f of alpha, it means that wherever we find x, we shall be putting alpha. So it will be alpha minus alpha, the whole of this is 0, so it is going to be a alpha plus b. I call this my equation 1. And f of beta, wherever there is x, we shall be putting beta. So when you put here beta, it will be beta minus beta, the whole of this one becomes 0. So we shall have a beta plus b. Sorry, this is b, not beta. I call this one my equation 2. By subtracting equation 1 and 2, the way we are doing sort of simultaneous equations, we can get equation 1 minus equation 2. You're going to have f of alpha minus f of beta is equal to b and b will go. So I have a alpha minus a beta. So this is f of alpha minus f of beta. To give you, I factorize out a. So a into alpha minus beta. What does it imply? We can divide by alpha minus beta to get a. So my a is going to be f of alpha minus f of beta. I divide by alpha minus beta. Members, if I'm clear with you here for the value of a, type yes. If we are together on value of a, type yes. If you're with me on getting a, type yes. It's not different from the method I've been doing. Yeah. It's not any different from what I have been doing. Someone is saying, teacher, pardon. You say pardon here. I can't pardon the whole thing. You say pardon here. It's a matter of knowing the form to which this is written. After knowing the form, because this is the divisor, they have given me everything in the question. Equate the divisor to 0, get x as alpha, get x as beta. Substitute x as alpha and get the first equation. Substitute x as beta, get another equation. Subtract the two equations. F alpha minus f beta is this minus this, this minus this, which gives this. Factorize out a being common and divide by alpha minus beta. It will give you the value of a. So after that, after getting this, we go ahead to get the value of b. And how do we get the value of b? You have to substitute the value of a in any of these equations. For instance, in equation 1, yeah? So substitute value of a into equation 1. When you go to equation 1, this is my equation 1, so it means that you have f of alpha is equal to a, the value of a, times alpha. So I can say alpha times the value of a. Remember, the value of a is f of alpha minus f of beta. Everything is out of alpha minus beta. Mathematically, you know that when we are multiplying fractions, this multiplier will multiply into the numerator only. So f of alpha is going to be equal to a. we have a plus b. So it is going to be alpha f of alpha, I'm multiplying alpha inside, minus alpha f of beta out of alpha minus beta plus a b, meaning to get b, I'll get f of alpha, b will be equaling to f of alpha minus the whole this. So it will be f of alpha minus, because I'm subtracting a big thing, put brackets, alpha f of alpha minus alpha f of beta out of alpha minus beta. This negative multiplied inside, so I'm going to have my b as f of alpha, yeah, to be f of alpha minus alpha f of alpha, then plus alpha f of beta, everything out of alpha minus beta. Divide by 1 and look for the LCM. So my b is going to be equal to, it will be f of alpha into alpha minus beta, because there is 1 times that. So minus alpha f of alpha plus alpha f of beta, everything I divide by alpha minus beta. So this is going to be equal to, we multiply, it will be alpha f of alpha, alpha f of alpha minus beta f of alpha minus beta f of alpha, I'm opening that bracket, then minus alpha f of alpha, then plus alpha f of beta, divided by alpha minus beta. Alpha f of alpha minus alpha f of alpha. This one will cross with this, and I can begin with a positive one. I can say alpha f of beta minus beta f of alpha, everything out of alpha minus beta. So that is my value of b. I have the value of b, I have the value of a. But my proof has x's. But those x's will come as a result of substituting into the remainder. The remainder is equal to ax plus b. So since you have the value of a and the value of b, we can go ahead to look for the that remainder. Members, I'm screenshotting these things, so you're going to get them in the group, because I really need us to understand this concept very well. So to save time of copying the work, let me cross it and go to the continuation. But remember, remainder is equals to ax plus b, and we've already gotten these values. So the remainder is going to be equal to the value of a. The value of a, we got f alpha minus f of beta over alpha minus beta x. So in the whole of this one, we shall multiply x, then plus b. But my value of b is alpha f of beta, yeah, minus beta f of alpha, everything is over alpha minus beta. So this is going to be equal to, multiply x to be x f of alpha minus x f of beta over alpha minus beta plus alpha f of beta minus beta f of alpha over alpha minus beta. Since the LCM is the same, I can consider the numerators under the same LCM, xf of alpha minus xf of beta plus alpha f of beta minus beta f of alpha, everything under the same LCM, which is alpha minus beta. This is the same as the ones with the f of alpha, bring them together. The ones with f of alpha, bring them together. So I will say x f of alpha, another one with f of alpha is this, minus beta f of alpha plus alpha f of beta minus x f of beta. The result, I'm dividing it by alpha minus beta. Go factorizing here, f of alpha is common. Since f of alpha is common, I will factorize it, meaning it will be x minus beta into f of alpha. X minus beta into f of alpha. Then here, f of beta is common. So plus, since f of beta is common, I will say alpha minus x. Alpha minus x. Then f of beta, then everything out of alpha minus beta as my remainder and as required. So that is what you're supposed to get as your remainder for that. I can't go beyond this. I want to have sent it to your group in case you are not copying, so that you take much time and you go through it. I'll wait for you at exactly 11 for organic chemistry. Yeah, my network is very stable. God helped me and worked on it well. So I wish you the best, guys. I wish you the best, guys. See you. These things are very, 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 very easy and easy. Thank you for attending. Wish you well.
So I might go and buy some things.